All right, so integer exponents, scientific notation. Everything that we need to know is already in the title. First, what are integers? Oh boy. And we've come to a grinding halt. What are integers? Just take a guess. Whole numbers. Whole numbers are a part of integers, but there's more to integers than just whole numbers.
Isn't it any number that's not a fraction?
I'll buy it. It's any number that's not a fraction nor a decimal. Positive and negative numbers are integers. Positive and negative whole numbers are integers. So Jacob, you gave us the positive side, but you didn't give me the negative side. So that's what I was looking for, was the negative side. Now, we do have a rule that we've already learned that helps us with integer exponents. All right, and it's called the negative exponent rule. And remember, what this says is that if you have a negative exponent, and I just put it over 1, then if you flip it or reciprocate it, that's the fancy math word, that exponent is now positive. Okay? Now, as beginning mathematicians, or Padawans, if you will, we like positive exponents. Therefore, anytime we do a problem, we want to make sure that our answer contains nothing but positive exponents. Does anybody know what a Padawan is? Because I did refer to all of you as Padawans. It is from Star Wars. What is it?
Student.
A student, very good. It's a Jedi Knight in training. So we're going to simplify the following. 2 to the negative third power. Now, we know we like positive exponents only. So, this is really 2 to the negative third over 1, which means if I flip it, it becomes 1 over 2 to the third. And 2 to the third, we can do that. We can do that in our head. 2 times 2 is 4, and 4 times 2 is what?
8.
Thank you very much, Megan H. Austin, what's for lunch today? It better be good.
Pork and noodle.
Oh, that sounds delicious. All right. Let's try another one like this. So we have 4 to the negative 2. Go ahead and do it. Let me know what you get. What do we get? I agree. 1 over 16. So let's look at it real quick. Remember, 4 to the negative 2. If you want to make it positive, Reciprocate it. Now, 4 to the second power is 4 times 4, which is 16. Okay? And this idea of reciprocating it works even if you have a problem like this. Why can I not write a 3 today? I know why. Endgame got me all flustered. So we have 1 over y to the negative 3. Now, if you bought into what I've been saying, which is if you got a negative exponent, reciprocate it, it becomes positive. What's the reciprocal of 1 over y to the negative 3? Y to the third over 1, or just y to the third. I think that was Wesley. Very good. Good job. Does that make sense, everybody? So we don't have to make this too complex. It's understanding, okay, I got a negative exponent, and no matter where that is, if it's in the numerator or denominator, I know that if I reciprocate it, it's going to be positive. Does that make sense? Even if you had a problem like this. One over 5 to the negative 3. The first thing I would do is reciprocate it. Make it 5 to the positive 3 over 1. Now, 5 to the third is 5 times 5 times 5, which is 125. So far, so good, everybody? Now, here's the crazy part. This idea of flipping things also applies to quantities. Now, remember, quantities are things inside parentheses. Like this. Two to the negative 3, all raised to the fourth power. Well, if I took the inside 2 over 3 and flipped it, now that exponent is going to be positive. Does that make sense, everybody? So from here, 3 to the fourth is kind of large. It's 81. 2 to the fourth is 16. And here's the best part. I know 81 over 16 is completely reduced. And I know that because 3 over 2 was already reduced. Sydney, how are we looking so far? All right, good. Good. Now, all I'm going to do is just start, I'm going to just start throwing some problems at us. Okay? Goal here is just to simplify it. We don't like negative exponents. What do? I am open to suggestions. Flip the inside. So, tell me what to write. Perfect. Excellent. Squared on the outside. Now, we know from here we can further reduce this. Because remember that power of a product rule? Remember that, everyone? Notice everything inside always has an exponent. All right, they're all little number ones. So what I can do is I can say, okay, well, let me get a red marker here so you can see exactly what I'm talking about. First, that negative sign is inside the parentheses, and it's squared, which means it's going to be positive. Second, n to the first raised to the second power is n to the second. Does that make sense, everyone? Remember that rule? Now, if we look in our denominator, that's 6 to the first. Well, that's going to be 6 to the first raised to the second power, or 6 to the second. And the same thing for the m to the second. Since the exponent on that number 6 is a very small number, it's a 2, you should write that out. So the final result is n to the second over 36 m, as in my God was endgame bad, to the second. And then you circle it. Good or bad? I think this problem, honestly, was a doozy. Because there's a lot going on in it. There really is. Okay? That is why you got to have those exponent rules on flashcards. And you got to practice, because you got to be able to recognize these things. Personally, when I see negative exponents, that's where I attack first. I just flip things. Then from there, I sit there and go, okay, can I use the product rule? Can I use the quotient rule? Can I do anything like that? And then if the answer is no, type in the answer, see if you get it right. If you got it wrong, ask your teacher. Click on it, and then I get a little email, and I can go ahead and write something up for you real quick. All right? Are there any questions? All right, now there is one thing that we do got to be careful of, okay? Because I'm going to give us two examples, and they're different. The first one is 6 times 3 to the negative 1. And the second one is the quantity of 6 times 3, all raised to the negative 1. So remember, order of operations. You got to do exponents first. So in part A, this 6 is raised to the first power. That 3 is raised to the negative 1. So the first thing I'm going to do is rewrite 3 to the negative 1 as 1/3. Now, I'm going to multiply. 6 times 1/3 is 2. Another way to think about it is 6 divided by 3. Okay? Now, watch how different part B is. Part B, you have 6 times 3 raised to the negative 1. Since you have parentheses, do the work inside if you can. 6 times 3 is 18. Now you have 18 to the negative 1, which is 1 over 18. Two problems that look similar are actually very, very different. Okay? Now, before we move on, in 6.7 in your book, they have just a summary of exponents. That's all the rules we went over. That is what I'm going to be testing you on. Excuse me. If your exam is 15 questions, 10 are going to be this. 10 of them. 2/3 of your test will be this. The other third will be one problem using long division with no missing terms. One problem using long division where you got to fill in the terms. And then the other 3 problems are going to be what we're doing now. So now what we're going to move into is called scientific notation. How many of us have taken a chemistry or physics course before or are currently taking it? Scientific notation will always have this form right here. It's going to be the letter A, okay, which is going to be a decimal, or it could be a whole number. We'll get there in a second. And that letter N it's going to be an integer. Okay? It's going to be an integer. Now, what I'm going to teach you how to do first is convert from decimal notation into scientific notation. All right, so number one, decimal notation to scientific notation. So one of my favorite numbers is the speed of light. Hold on one sec. It's 3.8. I just forgot it. Give me 1 second here. Sorry. There we go. Now I just want to erase. I can't believe I forgot how many zeros were in it. Boy, I feel dumb. Just trying to clean up the number here a little bit. All right. So here's the speed of light. 1, 2, 3. 1, 2, 3. It's 380,000 meters per second. We drive in a car, and we usually drive 65 miles per hour. So maybe I should put this in an hour notation. So light, when you flick on the light switch, it will travel 186,000 miles per hour. The Earth is spinning 1,000 miles per hour. It is moving through the solar system at 68,000 miles per hour. It's crazy how fast everything is moving, but the Earth is so large that we don't even feel it. Okay? How do we convert these numbers into scientific notation? Let me show you. So these are called decimal numbers because they're written in the decimal system. Now, if you read like an engineering book, what they do is they kind of space out the numbers, and I think that's a really good idea. So the decimal on 186,000 is going to be on the far right. Our goal when converting from decimal into scientific notation is to take this decimal place and move it into the first non-zero numbers, the first two non-zero numbers. So 186,000 turns into 1.86 times 10. Now here's where this exponent kicks in. Anytime you move a decimal left or right, what you're really doing is you're either multiplying or dividing by 10, respectively. Hence the decimal system. So since I'm moving to the left, I'm going to count the number of places I move. So this is 1, 2, 3, 4, 5. Since I move to the left, it'll be positive. So 186,000 turns into 1.86 times 10 to the fifth power. Now this times 10 to the fifth, all that means is that you were moving the decimal place. Does that make sense, everyone? All right. So let me give you one to do here. Oh, why did I pick red?
Why is it always 10 and then an exponent? Why is it always times 10?
Because that times 10 tells me you're removing a decimal point. Here, Leah, you ready? A long time ago, you learned this. 15 times 100. Now, old school, you would set this up. You would say 5 times 0 is 0, 5 times 0 is 0, 5 times 1 is 5. Then you have to start in the tens position. So 1 times 0 is 0, 1 times 0 is 0, 1 times 1 is 1. And you would say 100 times 15 is 1,500, right? The shortcut we taught you was count the number of zeros there's two of them, and add them to the end of your problem. Would you agree? Well, now with scientific notation, this is telling me take my decimal place, move it to the right, 2 spots, fill in the blank. Because this is really 15 times 10 to the second. Because how many zeros do you see? So you're moving it to the right 2 spots. But I don't want to get bogged down in moving left or right yet. All right? Because that means something. So what I want us to do is do 4, 3, 4, 0, 0, 0, 0, 0, 0, 0, a bunch of them. So let me zoom in so you can easily see them. Convert that number into scientific notation. Sorry, Megan. Can you see the zeros? Did anybody get an answer yet? Go, Wesley.
I got 4.34 times 10 to the 9th.
All right. Let's just see if you're correct. Remember, decimal point is on the far right of a number. Now I'm going to move it to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9 spots. So it's 4.34 times 10 to the 9th. Okay? Any questions with that? All right, so I'm going to leave this up here. Because now we're going to do the exact opposite. All right, now let's see how smart we are. Here I have a very small number, 0.000521. Okay? Now, if I want to write this in scientific notation, I guess I need to go in the opposite direction. Would you agree, Dylan? In terms of moving the decimal. I'm sorry, I should have been more specific. Would you agree, Dylan?
Yes.
All right, so 1, 2, 3, 4. So it goes in between the first non-zero digits, the first two. So this would be 5.21 times 10 to the. Now, if I move to the left, my exponent was positive. If I move to the right, I guess the exponent must be what then?
Negative.
Good. And now what we can do is we can kind of give ourselves like a little rule. Okay? So to convert from decimal to scientific notation, boy, it'd be great if I could spell. Step 1. You want to move your decimal to the first two non-zero digits. Okay? Basically, what you're looking at is this. All right? This is what you would see if you would read like a science book or even our book. This 1 is less than or equal to A, which is less than 10, is saying move that decimal until you get a number that's in between 1 and 10. So just move it until you get a whole number and then some decimals. Step 2. We're going to write the times 10 to the n part. Okay? Now, If you move your decimal left, n is positive. If you move your decimal to the right, n will be negative. Okay? So now that we have these rules, let's just do 2 more examples, and then we're going to go the opposite way, which is scientific notation back into like a normal number that we would see. Oops. So here's the 2 examples. All right, so step 1, I'm going to take my decimal and move it into a whole number and then some decimal places, or 2 non-zero numbers. So 1, 2, 3, 4, 5, 6, 7, 8. So there's my whole number, 2.01 times 10. And since I moved it to the right 8 spots, it's negative 8. Good? All right. Here's the other example. $4,031. Decimals on the right-hand side. I move it 1, 2, 3 times. So it's going to be 4.031 times 10. And since I moved it to the left, it's going to be positive. Are there any questions? All right. So now that we learned how to go from decimal notation to scientific notation, we're going to do the exact opposite now. Now I'm going to be giving you numbers in scientific notation. All you got to do is write out the number. So let me show you just how to do it, and then we'll write our rule out, or we're going to write out our steps. Dawn, what's your favorite number?
6.
All right, so if we think about this, hopefully this makes sense. First, the example we have, 6.31 times 10 to the 7th. Now, we know if that exponent times 10 to the 7th, we know if that's a positive number, we should get a very large number. Is that correct? Given the previous examples that we looked at. So, what you're going to do, and I think the easiest way, is just to write out 6.31. And then since we're going from scientific notation to decimal notation, we're going to go in the opposite direction. In other words, we're going to make this number larger. And to do that, we move the decimal to the right. So watch. 1, 2, 3, 4, 5, 6, and 7. Now, what I just created to me kind of looks like the bottom of egg crates. Or you know when you buy eggs. And always remember, before you buy the eggs, open them up. Wiggle each egg to make sure none of them are cracked. Fill them in with eggs. And then just rewrite the number nice and clean. 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5. So 6.31 times 10 to the 7th is really 63,100,000. Now, for the second example, I have 3.14 times 10 to the negative fourth. Now, from the previous examples, we know if that exponent is negative, we must have a really small number. Really small numbers are going to be less than 1. They're going to be decimals. They're really small. So, write 3.14. And I'm going to move this to the left 1, 2, 3, 4 spots. Fill in my eggs and just write it neatly. Does that make sense, everyone? All right. So, our steps then, step 1, locate the decimal. Let me write it like this. Step 2, in the times 10 to the n part, if n is positive, move left. If n is negative, move right. Wait. I got those back. No, wait. I got those backwards. What a dummy. I hope you're not writing in pen. As soon as I wrote that, I was like, that doesn't make any sense. So if n is positive, you move your decimal place to the right. If n is negative, you move it to the left. All right. Are there any questions? All right. So I think now the big part is, why do we do this? Okay. Why do we do this? All right. So let's say we wanted to multiply the following numbers. All right. I don't know about you, but I never ever want to do this problem. I know the answer is a 6 with a bunch of zeros after, correct? Also, there's a lot of zeros I wrote there. Here is why we do this, okay? If we can convert these numbers into scientific notation, or better yet, let's say the numbers are already in scientific notation. Watch how easy this is. Read the numbers. 3 times 10 to the 15th times 2 times 10 to the 9th. Does order matter when you multiply, anybody? I agree. So if you wanted to, which I encourage you, multiply 3 times 2, which is 6. Times. Now, look here. You have 10 to the 15th times 10 to the 19th, or 9. 10 to the 15th times 10 to the 9. Isn't there a rule that we learned that when the bases are the same and you're multiplying, what do you do with the exponents, Megan H? So what's 15 plus 9? There you go. I was going to say you can phone a friend and that friend will be me. So the answer to this problem is 6 times 10 to the 24th power. Does that make sense? Here's another one. Four times 10 to the 5th times 2 times 10 to the negative 7. Remember, order doesn't matter. So nobody says you can't do this. All I did was I rewrote it. 4 times 2 is 8. Oh, sorry, I put a negative there by accident. 10 to the 5th times 10 to the negative 7. Well, bases are the same. Add the exponents. 5 plus negative 7 is negative 2. So our answer is going to be 8 times 10 to the negative 2. Does that make sense, everybody? I mean, we could do this. Go ahead, I'm listening. Somebody going to ask a question? Actually, let's make this a larger number. We'll make it an 8. I like 8 better. So we have 24 times 10 to the 4th divided by 8 times 10 to the negative 2. Now here we need to be careful. 24 divided by 8 is easy. That's 3. But 10 to the 4th divided by 10 to the negative 2. I'm going to write it off to the right-hand side. 10 to the 4th over 10 to the negative 2 is really... Remember, put your parentheses there. 4, negative 2. That's really 4 plus 2, which is 10 to the 6th. Does that make sense, everyone? So that is all scientific notation allows us to do. Is we could take really large and really small numbers, which you end up working with in chemistry and physics, even biology, I mean, even in economics. Nobody wants to write 24.6 trillion every single time. So they write 24.6 times 10 to the 14th or something, or 15th. That's what they do. Okay? So it just allows us to quickly do math with really large or really small numbers because we can use our rules for exponents. All right. Are there any questions with this? Yay or nay? Will there be homework on this section posted before the test? Absolutely. In fact, I'm going to do it right now because I already have it done. Any other questions? Are you sure? All right. Well, I am done for today.